Hi, data friends. I'm Nick. I work at the W.P. Carey School of Business, and thanks for joining me. And I wanted to share with you some cool stuff that I've worked on at work. Um, I had this crazy idea. I wanted to visualize the migration pattern of some of our grad students, and I got this idea from an article that I came across. There's there's a website out there called Towards Data Science, and I read them a lot, and you get a sort of weird ideas about how to do cool things with data. And I thought that seems like fun. How can I do that? So I did some reading, and I was trying to figure out, like, how would I calculate distances between places, right? And you're trying to figure out, like, so you've got a student who is a student and where they live when they're students, and then where do they live when they're graduated, when they're alumni. And you basically have 2 points. You have point where they lived and point where they live. And so that distance here is what they call the Euclidean distance. And I thought that sounds complicated. So I did some more reading, and I figured out that in order to achieve this, you need to calculate the distance between two addresses using what's called the lat and the long, the latitude and longitude XY coordinate of the addresses, by using math. And I hated math in school. I hate it even more now, which is why I got into computers, because computers makes math easier for me. I did some more reading, and I came across another cool article. If I can find it, did I bookmark it? It's somewhere else. Anyways, there is an article out there which explains that the Euclidean, oh, here it is. The Euclidean distance formula is nothing more than the Pythagorean theorem, which we might remember from when we're kids, which is that c equals the square root of a squared plus b squared, and that's probably a little more manageable than the Euclidean one, which is like all sorts of nuts. So the Euclidean one is in 3D space and it's complex. I didn't want to mess with this one. I decided I wanted to mess with this one because it had less letters and it was something that I could probably manage. And so I thought, okay, let me start pulling some data in to whatever system I wanted to play with and see if I could do some math. And so what I decided to do was I needed to pull data I needed alumni data, and then I needed data from students when they were here. So the two data sources that I needed to work with was data from what's called the foundation. Foundation is like, I think of it as data from across the street. We have the foundation, the Fulton Center, I think it's called the Fulton Center, across the street where the foundation is, and they house alumni data. And then we have over here on our side of the street, we have our data warehouse, which houses PeopleSoft data from where, when students are students, that's where their data lives there. So foundation data apparently has latitude, longitude data already stored in the tables. However, the PeopleSoft side of things over at ASU does not. And so I made this graphic to kind of break up the monotony of math, because math is not fun, but this drama llama is hilarious, right? So anyways, now that we're laughing and we're done laughing, we're going to the next slide. What I needed to do was I needed to convert addresses that were in our PeopleSoft tables into latitude, longitude, XY coordinates. And the way I could do that was using a tool called Python, and there's libraries in Python. Python's really cool programming language because there's all these really cool libraries that you can import to do all sorts of cool things for you. There's a technology or a thing called Geocode, which is like a simplified way of explaining is like an XY coordinate for an address, for a spot on a globe. And it's actually what this article is about how to convert mailing addresses into XY coordinates. And I thought, that's cool. Let me see, how can I do that? So I came up with, in the theme of food, a recipe. And I like to use the word tools because I think of things in terms of tools. And so this is like a list of tools. If we had a cookbook, this would be a list of my ingredients. My data sources are, I have my foundation data, which houses all the alumni that I'm starting with. I then have to get data out of our Redshift data warehouse on the ASU side of things. And then at some point, once I do all the magic, I have to dump it into a database here from which I can do reporting. And so we're going to use the AUDB database. The software that I'm going to use, the tools I'm going to be using to do all this work, inside the BI desktop, I'm going to use SSMS as a tool to help develop my query to pull data out of the Foundation Advancement database. I'll use dbeaver as a database tool to pull data out of the out of the PeopleSoft data warehouse, Redshift data warehouse. I'm going to use Alteryx as my tool to do all sorts of mangling and pulling things in and out of places and putting it back together. I'm going to use Anaconda and Jupyter Notebook to do the Python side of things. And the reason why I'm doing that is because I cannot, in our BI desktop, I can't connect out to the Geocode library to upload, or the Geocode library cannot upload data to its service because our BI desktop is sort of locked down. So what I did was I ran it locally on my computer, and I just basically printed CSV files into my like a shared folder. And then on my local computer, I used Anaconda, ran a script in Jupyter, printed out another set of data which had the geocodes in it, and then married it back to my original data in Alteryx. And then I used the geocode library, and then I used Tableau to visualize all the stuff. And I wanted to add this, I used Excel because we always use Excel. I think a lot of people who use data sort of at this kind of level, we try to say, oh, we don't use Excel, it's for kind of amateurs, but I use Excel all the time because sometimes it's just really easy to open the file up and look at it. So the steps are, I pull and filter alumni data from the foundation. When I say filter, if I pull data for, let's say, our college, I don't need certain types of records, like records that are older than ones that were stored that have equivalents in PeopleSoft, for example. So anything, let's say, before, I'm making up a date, 2007, 2008. And then the next thing is I need to figure out like the MPL IDs from those, and I have to pull the addresses out of PeopleSoft on the ASU side of things. I then have to get those addresses and convert those into geocodes using Python. And then I have to join that stuff back to the original foundation data. I then have to, I missed a step here. I need to calculate distance. And there's a tool in Alteryx that does that for me, which is one of the really cool things about Alteryx is it has spatial data tools. So instead of me doing the math, because I hate math, this thing does it for me. I just plug in the XY coordinates from Foundation, XY coordinates from PeopleSoft, put them in as two data sources, and it does the math for me, and it spits out a distance field. Then, very important, I remove identifying information because I'm going to publish this in a place for us to look at. I don't need to, because this is where people live, I don't need to know who these people are. I'm just interested in things like programs, demographic information, male, female, ethnicity, date of graduation, that kind of stuff. I need to publish it to an AUDB database table, and then I have a dashboard already built in Tableau. I just need to refresh it so that way it has the data ready to go, and then I'm done. And then the output, And this is a simplified version. I'll actually show you what the Tableau dashboard looks like. It'll look something like this. And this is a sample of the data because there's a ton of records and it takes a long time for Tableau to calculate where all the dots are. So I just did a sample of 1,000 records so you can kind of get a sense of what you see. These are just two program plan codes. So I'll show you what's actually going on under the hood. So let's take a peek. If we go into the BI desktop here, I use SSMS to write my SQL code. And the reason why I use this is because developing code in Alteryx is a nightmare. So I develop it here just to test it, make sure it works. Once I know it's working, I copy and paste it into Alteryx here. And then I have this big, giant, messy, I suppose in the spirit of food, I could say this is like a street taco. It's like the street taco of Alteryx workflows, but it's pretty big. Going from left to right, I have another workflow which pulls, it's like a massive alumni data pull that I run weekly. That data pull starts out as my source, and then it goes from left to right. I just do some filtering. I extract some EMPL IDs. I pull data out of PeopleSoft. I join it back to the foundation data. Then I do some more address filtering. And then down here is where I dump it to a CSV file that I run in, that's going to be used in Python. And then in Python, now I'm on my local machine. I have Anaconda running here, and I have a Jupyter Notebook here, which is running a script which opens that data file that I just printed from Alteryx, and it runs through and it goes through all of those records, and it converts each one of those mailing addresses into these latitude, longitude coordinates. So I got 1,000 of them. This took about a half hour to calculate. And once it's done, it prints the encoded addresses back to another CSV file. And then I go back into Alteryx, and then I have it load that file right here. And it does some more kind of tinkering with it to bring it back up into here. And then right here is where that spatial craziness happens, where it takes the two sets of latitude, longitude coordinates and it calculates the distance between them. And then it spits out a new distance record column. And then that stuff gets joined back to the original data. And then I spit it out to my data set in AUDB. And then that looks like this when I'm all done. So I have my foundation latitude, longitude coordinates. I have my brand new, these are the two new columns that I didn't have before. And then the distance column right here, this I didn't have at all. So this is the calculated distance between these coordinates and these coordinates here. You'll notice here I have no identifying information. It's all record ID is just from 1 to 1,000. And then I have other information like gender, date of birth, some ethnic stuff. And then I have their some basic information about when they graduated, the programs, and the kind of degrees they got, college they graduated from, et cetera, et cetera. And then the final output looks like this. Sorry, there we go. It looks like this in full screen. So this is just a very simplified version of my dashboard here because it's full of data and it's super slow. What I wanted to illustrate here was that I have two programs displayed. I'm starting here. Up on top this is a map of students who are from Arizona. They lived in Arizona when they went to school here. And of course they lived in Arizona when they went to school here. I mean, they went to high school in Arizona. They grew up in Arizona. This is their home. And then this map down here shows where they lived after they graduated. And I'm showing two programs. In blue, we've got our full-time MBA program, and in sort of purple, we've got this Masters of Science Information Systems. Let me stop that. And if we show in distance here, this shows people who've moved about 306 miles away from home after graduating. Now, as I start to crank this up all the way to the right, something very interesting is going to happen. Boom. And what's interesting is that you'll see that full-time MBA students tend to move east. You have a bunch who live in Oklahoma, Texas, Florida, over Boston, I'm guessing, and then a lot of business, financial centers over here, insurance and stuff. Some move to San Francisco, but you'll find in the information, the BA Info MS, nobody moves east. Don't know why, but this is one of those things that when you're playing with data, you sometimes have to build these wacky little tools just to see like, huh, that's weird. I wonder why this one program doesn't move east after they graduate. Is it because the market for the kinds of jobs that, you know, that these people gravitate towards only happen to be here? Who knows? Like, anyways, that's kind of the point of visualization is you're like little, they say data scientists. I don't like to use that. I think it gets overused sometimes, data scientists, but really I'm just kind of tinkering like a scientist might, just experimenting with data and having fun. And yeah, so I think I have about 3 minutes before my time is up. So I'm going to stop right there. And if anyone has any questions or comments, I'm going to leave it open. And that's it. Hi there.
Thanks, Nick.
Someone has their hand raised, and I'm happy to answer your question.
Yeah, I just had a question regarding how do you manage the different types of data that you bring in, that you are bringing in from the different sources? Like I do something very similar in my work where I am bringing some data from Foundation, something from Oracle, something from the user tables. And when I use Alteryx to put them all together, the systems kind of gets very messed up with the different data types. How do you manage that?
How do I do it? I block off about a week in my calendar. I'm being facetious. Seriously, I use the metadata tab, and I take notes on. I have a sheet on what I want my data to look like, and I keep it open. And I then look at my data sources or whatever is coming in, and I use the select tool or a combination of like formulas, combine, you use them in different ways, but to make sure that as stuff comes in, especially if it's like a CSV file, because those come in as only strings, that I make sure that they convert to the correct format, the right size and all that stuff. I'm not sure if I answered your question.
Yeah, Vince, I was just looking to identify which tools could I possibly use for doing that. And yeah, so that
the
helps.
select tool, you can change format types, and then
Right.
you can also use the formula tool. So you can, like, for example, if you have a string, you have to convert it to a number. There's like,
Right.
I think it's 2 number is a formula.
Mm-hmm.
You can change it there. And some things you can just at the bottom, you can just change it. Like it depends. Like it's, I know in the Alteryx test, you're supposed to know which ones. I don't remember. I just play until I get it right. Like it's kind of like a coin toss really, but I use a combination of formulas and the select tool.
Thank you.
Sure.
All right, Nick, thank you so much. I dropped in the chat the information that you need to access badges if you'd like to get a badge for your participation today, as well as the link that will take you to choose your next session. So thank you so much for joining us, and we'll see you in about 10 minutes if the next session starts.
Thank you, everyone. Bye-bye.